they actually spin up work for the first time. So that's a pretty comprehensive review of Spark pools. Now let's take a look at what we've actually got here. So here I'm inside of the Studio user experience. You've seen this before if you've been following along with this training series. But I've got it set to show the maximum amount of code on the screen. And that means I've got some of it collapsed in. And so you can see here, here's the workspace. Now I see here, you can see the long version of each one of the contexts. And we're going to spend most of our time today in the notebook area. And you can see I've got a series of notebooks loaded here. So the first thing we're going to do here is we're going to take a look at the list of Spark pools we have available to us. And you'll see that straight away, Live Demo is already there. So I can go ahead and use Live Demo if I want to. We're not going to in this particular case. I've already run this notebook in advance, and that gives us the 10 by large static. So this is a 10 node, large nodes static Spark pool in this particular case. One of the core concepts that we always have to remember about Spark is inherently a distributed system. It is designed to process data at high scale, high performance, using many nodes. And that means that when we operate on the data that it's got, we have to think about data slightly differently than if we were running things just on our desktop or on our laptop. The fundamental data structure that we have inside of Spark that allows us to do this is something called a data frame. Now there's a bunch of infrastructure underneath the data frame, but for the purposes of today, we're really going to focus only on the data frame. Now, if you're used to using data frames in Pandas for Python, or you're used to using Tibbles or data frames inside of R, very similar concept. It's a rectangular data, which includes some metadata, and it includes rows and columns, and you execute against it. You execute jobs against it. You execute code against it. And we can use a variety of different languages here inside of Spark. And you can see I'm going to use PySpark today because it's the most popular language for Spark. But I could also use Scala, and I could use C#, and I could also use Spark SQL. And we'll actually show you some Spark SQL a little bit later on. All right, so what we're going to do here. So first of all, we're going to create a new data frame. And instead of loading it from file or loading it from a table, we're simply going to create one from scratch and keep the data set as simple as we possibly can. And so here we're going to create two columns, which is database and user count. And then we're going to have some data. Obviously, Spark is going to be the most popular database. So we have 20,000 users for Spark. We have 10,000 users for SQL, and we have 3,000 users for Cosmos DB. We're then going to take that data and we're going to parallelize it so that it doesn't just run on a single node. Obviously, it's quite small data, and so it would all fit on one node. Remember, we have 8 gig per vCore, and here we're running 8 vCores, so we have 64 gig of RAM available to us on this one node. But we're going to go ahead and distribute it by doing parallelize. Then here, we're going to turn it into a data frame. And we're going to call that data frame SDF1 for Spark data frame 1. Spark actually supports multiple different types of data frame. Here we're using a Spark data frame. It supports Pandas data frames and also Koala's data frames. And so using SDF is a nice short way to remember what type of data frame you're interacting with. And we're very quickly going to print the schema just to make sure it matches to what we created above. And it turns out we do. We've got the database, which is a string, and we've also got the user count, which should probably be a number, but we made it a string just to make things simple for just now. All right. So one of the interesting questions that we have to take a look at is, how is this data distributed? Remember, we asked for it to be distributed. And you'd expect with only 3 rows of data that the distribution would be relatively simple. Well, we can make this call here, and all this is going to do is look at the number of partitions that sit underneath that particular data frame that we're using. And you can see here that it's actually 8. Well, hold on. We only have 3 rows of data. How on earth do we end up with 8 partitions? All right, so if we take a look down here, we can see the distribution of the data across the 8 different partitions. Because here, the first 2, we have nothing. Then we have 1 row. Then the next 2, nothing. Then 1 row. Then nothing. And then the final row. So where does the number 8 come from? Well, the hint is up here. We're going to talk a little bit more about the relationship between executors and cores in a little bit. But in this particular scenario, the partition count is aligned around the core count. You should think of executors as the things which do work, and executors have memory and cores assigned to them. And we can actually go over here